Hello, math students. In this video, I'm going to be solving a quadratic equation by completing the square, but I'm also going to be using completing the square to rewrite a general quadratic function into vertex form, and then we're going to find the zeros of that function. Okay, so it'll be a two-step process, and you might see that this is a, quote, master level quadratic equation by completing the square, because it does cause us to have to handle a number of issues as we move along. So this is the equation we eventually want to solve, which is 0 equals that quadratic expression. But I'm going to start out by bringing in I'm going to start out by bringing in a different version of the equation, which is the complete function. So what do I mean by that? Instead of setting this equal to 0, I'm going to say, let's work with the function equal to y. So this will be a quadratic function. Its graph will be a parabola. And we're going to complete the square to begin by rewriting this in the form y equals a x minus h squared plus k. And you may remember from our unit on, or you may have seen this in the past, where we translate quadratic graphs left, right, up, down, and reflect it and stretch it and compress it. So you might remember that h is a translation left or right of the x squared graph, k is a translation up or down of the x squared graph, and a stretches or compresses it vertically in the y direction, stretch or compress, and it also, if it's negative, it will flip the graph over the x-axis. So rewriting a function into its vertex form is really helpful for graphing and for finding the vertex, because then the vertex is h comma k. Okay, let's do it. So we're going to complete the square of this general function, and here we go. First step, we need the leading coefficient of the x squared term to be 1. And we do this by factoring out the 5 from the terms with x. So if I factor a 5 out from 3, I will get 3/5. And then I don't want to factor the 5 out of the 1. I'm going to leave some space, and I'm just going to do this. So I've only factored the 5 out of the two x terms. Now we have the step where we need to complete the square. And you might remember that the shortcut for that, or the trick, is to take, I just realized I forgot to write the x there. So I factored the 5 out of the 3, and I got 3/5 x, and I left some space here. Now, what we do is we take the b term, or the term in front of the x, we take the term with x, and we take the coefficient that's in front of x, 3/5, and we multiply that by 1/2, or divide by 2. We take that result and we square it. When that coefficient is a fraction, like 3/5, I prefer to multiply by 1/2 instead of divide by 2. It's the same thing. It's just easier to write. So we do this and we get 9/100. So that means 9/100 is what we need to add and subtract to the quadratic expression to complete the square. So I will add 9/100ths, and then inside the parentheses, I will subtract 9/100ths. Okay? All right. Next step is we want to distribute this 5 to the one we subtracted, and only that one. So 5x squared plus 3/5 x, and on the inside we will still have the plus 9/100, but on the outside we will have minus 5 times this, and we'll get 9/20. Okay, so we've only distributed the 5 to the one we subtracted to get it out of the parentheses. And the reason for doing that is because this is a perfect square trinomial. So we can factor that with our square factoring pattern. Let's clean that up. Y equals 5. Now this is x plus and square. Now what goes here? It's the square root of this thing. It's 3 over 10. And you'll also find that whatever you calculated inside the parentheses up here is always what goes here. It'll work out every time. So this will be 3/10. And you can check that if you square this out, it will be this. And that's why this trick always works. All right, so now on this outside, minus 9/20 plus 20/20 is plus 11/20. So we'll add those two numbers together. And now we have done it. We have gotten this into vertex form. So the vertex of this is negative 3/10, comma 11/20. Okay, so that's helpful if we were doing graphing. We also can see that the graph is stretched vertically by a factor of 5 if we were transforming x squared. And we also know, since this is positive, that the graph will be oriented vertically this way, so the ends will point up. Okay, now remember our original question was to solve for this equal to 0. Let's do that. So we will just substitute y equals 0. And we're going to find the zeros of this quadratic function. And it's just a matter of doing the basic algebra. And I can already see that I have a negative number on the left. And I can already see that I'm going to get non-real zeros here. Divide both sides by 5. Square root of both sides. Square root of negative 11 is I root 11. Square root of 100 is 10. And our two non-real solutions are negative 3/10 plus or minus I square root of 11 over 10. Okay, and we have done it. And just to summarize, completing the square has multiple uses. We're going to see more uses in the future when we get to conic sections in another chapter. But one important usage is to be able to rewrite a quadratic function into vertex form. And that's useful for graphing. It's also helpful for finding the vertex, because the vertex is the highest or lowest point on a parabola. So we can find its maximum value or its minimum value. But we also can use it to write it in this form so that we can find the zeros of this function by setting y equal to 0 and solving. And in this case, it has no real zeros. So this parabola would have no x-intercepts. All right, that's it. I'll see you in the next video.